All right, and I'm back. Okay, so what are we doing today? We are working in Purescript, and well, there's a few things that I was exploring last time, um, and I want to get back into that. Um, I think I extended the complexity of everything quite significantly. Let me lower the music a bit for me. Okay. So let's, right, so this is, I think, what we were looking at. So the current prototype that we were working on was based on this Purescript SDOM library. And we kicked the tire of that. It was an experimental project. And I'm looking at going towards something maybe a little bit more well, a little bit different. I don't know that it's necessarily a bit more robust. It's also an experiment, and it's PureScript React Explorer. So that's one of the possibilities here. Um, the other is that I want to put something underneath that has more of an event approach, an event-driven approach, and we tried to do this with PureScript as DOM. And I thought I'd try to basically go back to something that I've been experimenting with before I even started streaming, which is PureScript run streaming. So I think in theory these things could fit together. It will require, it won't be easy, but I think the work that I've done with PureScript run streaming will benefit from being put underneath PureScript React Explorer. I think it will straighten things out with regards to how UI will happen. Because I was experimenting a little bit with things about UI here, but I think the problem became a little bit complex to handle. And I mean, I think it's still pretty complex to try to assemble all of this together. But hey, that's I'm here to learn, and that's part of pushing a little bit my boundaries and trying to understand in what I understand. And maybe the motivation for trying to do this, I think, is to mix the best of different approaches to application development in general. Um, by sort of grounding our effort into existing patterns that are proven. So the fact that, for instance, in this approach that we will explore with PureScript React Explorer, that that it's basically a way to think about application architecture with a level of abstraction with pairings that should allow to at least have some, I think can allow to have some more clarity and composability in the possibilities that the app can surface, which is something that I haven't seen so much in UI or application with significant front end top layer. So we might, I think by using PureScript React Explorer, we might actually be able to plug in something else than React. In fact, the repo, I think, um, is hooked up to maybe different approaches, I think. We can take a look. And then on the other end of things, PureScript run streaming is also it is more of a streaming framework, a coroutine specifically, and so deal with sort of push or pull approaches to streaming, has this kind of bidirectional approach that pipes or conduits or machines have. So feel like they're kind of a good foundation for general purpose um, streaming um, programming approach. But what Purescript run streaming has that those other library I quoted don't have is that it relies on this extensible effects approach. So it should be more extensible and therefore allow to compose different things that stream together, hopefully in a way that is more modular and composable. But I don't know how these things will play together. I think this is an area that, as far as I can tell, is unexplored. So it could be because it just doesn't make sense, but we will try. Um, and I brought last time up this idea of having also maybe connecting to Dunai and Rhine, like the more functional reactive programming, like the tip of the spear in terms of functional reactive programming with type level clocks and whatnot. But I think we can probably completely let go of that because I will be exploring that also in my Saturday stream with Haskell, in which those libraries are developed. So that should also bring us up to speed on similarities and differences here, and maybe find like a common ground because I don't necessarily want to program with n different approaches. In fact, I'm trying to find find approaches that can be reused across different application domains or even programming languages so that I don't have to learn too many different things and I don't suffer from context switching friction and so on. Okay, so let's start by taking a look at our code, and actually maybe I'll also duplicate our previous prototype focus log and we can take a look at what's in here. That's kind of the to-do list that I had put in. Dive back into Dunai and Rhine. So I think we've moved this into the Saturday stream, so that's good. Dive back into play Purescript run streaming. So that's my experiments with Purescript run streaming. And I think that actually we'll start by doing Purescript React Explore. I think that is an interesting place to start. Plus, I suppose I remember that a viewer from last time that was seemed to be interested in that. So let's get up to speed and see whether we can see whether we can migrate our prototype to Purescript React Explore. That's going to be our first task. Although I suppose maybe a task of interest is to find my past experiments with Purescript React Explore, because I think there were some. They might not be in this folder, but it's worth a shot. And let me see if they could be in another folder. Okay, I already have way too many. Since it's down. Problem with my internet connection. Is that true? Okay, that's not good. Okay, no, it's fine. Or it was temporary. Okay. So yeah, I'm just checking. I think if it is in another folder, then I might not have it in this computer, but it's okay. If I did experiment, it was probably a fairly small scale one. So I think we can, well, first of all, we can do a little bit of cleanup. Let's see what we had here. Yeah, that's me waxing lyrical on the Junai and Ryan side of things. That was a nice chat with our viewer last time. and that's still it. Okay, part of my brain is saying, hey, you're not storing all of these important, valuable things as you've been doing in the past. Why not? So let's do this. I should have an extension for this. I'm not sure why it's not displayed. Oh, maybe because I haven't reinstalled it yet on this computer. That makes a lot of sense. So, what was it? Copy tabs, extension, home, tab copy. Yep, that's the one. We're going to need that. And we can copy all the things and put them in our log from last time, in fact. Yep. Okay. So, and we'll delete the links here. This looks like it's getting a little bit unwieldy, but should be fine. Okay. So I think this is pretty much where we want to start. I think this is some of the original thinking from Phil Freeman on Commodity QI. So we'll keep this. Let's take a look. I was trying to find when Chris interacted with Phil about Purescript React Explorer. I couldn't find it. I might keep this on the side because it has nice diagrams that I'm interested in, and I think we'll need this. We'll need this. Pipes, no need. That was our viewer, and okay, yeah, we can remove all that stuff. Good. And Purescript React Explorer will be our next protocol, and here it is. Okay. So, oh, okay, yeah, I'm downloading things because I'm muscle memory. Okay, so that's the module, and that's the repo. Okay, so let's look at what things look like here. I remember playing with this before. Oh yes, and I remember that, in fact, I was also trying to figure, because this work on Commodity QI has been picked up by a student, Commodity QI, Xavier something, Arthur Xavier, who seemed to have taken it a bit further. So it might be interesting to see where things went. That looks like an app that's built using this approach. That's going to be quite interesting, actually. And that seems like another one. And I think, well, yeah, we can look at which libraries were used. So React and React DOM directly. So, and it looks like, yeah, the commodity part here might be, yeah, I think it's checked inside the repo itself. It hasn't been published as a library, apparently. Yeah, we have combinators and React things. Yeah, I remember looking at this code. I think there's been some incremental changes made from the original formulation from Phil, and we'll have to take a look at that. Right, so explore is what goes on under the hood. I think this is the example, and I think this is not a bad place to start. So main takes this Elm prime variable. Let's define here. it gets it's a monadic value, it gets a window, a document, the example ID, and then yeah, there's an unsafe partial thing to get the example um, HTML element, and then it passes this as the to render UI. And so render UI is going to be part of the. Oh, actually, that's from React DOM. Right. Ah, yeah. So the thing is that we are not going to be inside React Basic or React Basic hook. So it might be another level. I thought maybe that's the work that I tried to do. So if I had done some work on this, it might be good to find it. Let's take a look again at our search. Aha. Aha ha ha. Yes, that very much looks like experiments of the sorts that I was talking about. So let's bring up all of these things and take a look at them. Okay. So what is this? I think this is yeah, this is an approach to an attempt to do some kind of high level design of the type that I was talking about, like trying to link the Purescript run streaming approaches and the monadic UI approaches and the monadic stream function approaches. That's very much sort of kind of thinking. And here, though, Purescript Command UI React Basic, I think that's what I'm talking about. But did I come up with that? Purescript, I think I might have. Command UI React Basic. Yeah, that doesn't exist. I think that's my attempt of doing this merger that I'm talking about. Great, great. So I found it, and we can probably just well, do we need to copy it? I think we might not even need to copy it. It's in the libraries folder, and there we're already getting things from the libraries folder here, if I'm not mistaken. Yeah, we are. Excellent. So you know what? Well, no, maybe we can't really quite import it just quite yet. But what we could do is open it in our project as a folder. So let's do that and add folder to workspace. There we go. And then we can open a terminal in here and do all of the Purescript installation things. And let's see, we do have a package.json, and we have a few dependencies like React and whatnot. So we're going to need to do npm install as well. Spago install didn't do anything. That's not necessarily good news. Oh, it's doing Spago install now, so that's good. Oh, I have an install, so it's just running the install. That's good. Okay, and so we'll start work. Not Spago, npm start actually. To build test.main unknown type store. Okay, so test.main. So it seems like that's, yes, one of the things I was trying to do. And it looked like I was trying to do a React Basic rendering component. And I think when doing that, I was trying to follow this approach, I think. Yeah, that's right. That's pretty much copy paste of that code. And then I was trying to have a test that would run. And then I suppose that there's some things that simply weren't here. Great. Oh, it makes me really happy to be joining my work from before. And you know what? I'm actually also going to do something else. I'm going to look up my log um, about, because maybe there is some work that's worth something that's worth reading about in my notes from then, but I do not see anything. So it could be that, okay. Ah, yeah, no, there are some notes right there. Excellent. And here too. So let's open those and check out where they were. They're from August and from, yeah, from the day before. Okay, what do we have here? Allocation of my attention. Yes, real time. Kit moving code. Yeah, so that's me doing some streaming stuff. And ideally, solution I use works with streams and FRP in the style of running. Deny access to persistent state with real-time subscription and queries. Relational constraint-based queries. Gears. Run. Ah, right. Right. So that's kind of like the kitchen sink. That's really all the things I want from my application framework. In Purescript React Basic hooks, we have, so that's, yeah, here it's me just copy pasting some very basic usage pattern for application just to have them in front of me that I can sort of, you know, stare at them for a while. So that's the Purescript React Basic hooks where you define the component and then you run a hook like use reducer, for instance, passing it some info, getting state out of it and a dispatch function, and then being able to then pass that on. And so with an action type. So that's, I like this approach quite a lot, you know, except that to me, this looks like what should be the algebra of a free monad. And so then it can be that the in the Purescript in the commonetic way, that in fact this free f that I guess exists here can pair with cofree g, and that starts looking like one of these example in Purescript React Explorer, not the library here, where and I didn't continue here, but yeah, the cofree example, for instance. So here our component is actually cofree, and so because it can react to a free algebra, and so the component is an interpreter for what actions um, the user or you know, external services throw at it. Purescript behaviors is the kind of FRP way, and we used some pieces of that when we were experimenting with Purescript as DOM. Specifically the event library that came out of that. In community QI, here we go. We see those things that I had just right there. We can do eco-free component, a store component, if we had a state monad paired with it, state and store, or free and co-free. And yeah, so that's just copy paste the code. I noted that there was a more complete example in Command UI to-dos, which we also opened. That's right here. And if I succeed in making a Command component the React Basic Hook component, then possibly I can have components that are an actual JSX component with hook. Right, right. So here the idea, looking a little bit more at where to-dos co-free app. So let's go in there. To-dos co-free app. Yeah, we have an app component here that I felt, starts to look a lot like this this hook component, this Purescript React Basic hook component. It's get passed a render function. It does some stateful things or effectful things at the beginning, and like here, there's an effect at the beginning, and then there's rendering that happens. So it feels like it looks quite a bit like what we'd like, and then also there's this. Well, there's a free functor right there, and so oh, PureScript get syntax highlighting. Or did it, or am I, it's just because I'm not used to having switched to the dark theme, maybe. Because I think it was using the Haskell syntax highlighter, wasn't it? Yeah, anyway. Let's make sure my stream is still on. Yeah, it says the quality is unstable. Well, yeah, that's not the best. Okay. So let's take another quick look here, because here we actually have the free co-free right there. We have the free algebra, the functor that we build our free monad for. We have right here the co-free pair for this free functor, and the proof that this is a pair, the instance that show that pair them, and so I just want to check how this is used up there. Unfold co-free. Oh, eval, I think, is what we're looking at. Eval, yeah, uses the app interpreter. Yeah. So eval takes a model because it's going to use the model in order to instantiate the interpreter as a model changing interpreter. So this is kind of a step function, you could say, or what's going to take a model and then it's kind of the reducer. You could see it as a reducer, right? Once we have the app interpreter, as soon as we get one of these two actions, then we know exactly what to do with the model that we've been passed. So we could say app interpreter is the partially applied eval, and then when you give it the model, then it knows exactly what to do. So I suppose another way to say this is that in fact we are instantiating the app interpreter for a specific type app model in such a way that so this app interpreter is actually abstract, but I suppose this functor is also abstract. But whereas the functor's A here, when it's made into a free monad, lifted into a free monad, then the A is the continuation. It's the action that comes afterward, including the done or return from the free free monad constructor. Whereas here, A is the state, and that fits my intuition of the fact that uh, a a free monad out of a base functor is the succession of actions. It defines a path, like a succession of action that can be connected to each other, but where they're connected to each other by which one came before and which one comes after, and some of the parameters that go into them. But they're really the exploration or the directions that someone, um, that if I have the metaphor would be that's the steering wheel in my vehicle, whereas the interpreter is the space that my vehicle is traversing, or where my vehicle is at any given moment. So if I turn left at one moment and then the next thing I do is I turn right, that's what, and then I turn right again and then I turn left again. That's what defines my the sequence of actions that I'm responsible for as the driver for the car. But the app interpreter there would be not a sequence of things, but instead uh, uh, changes applied to a state space. And in the car metaphor case, that would be where my car is, the car position. And so the car position knows that if you get a string or a direction, left or right, then it, when it gets it, then it knows what new position is going to be. Um, yeah. So this A here is kind of meant to be a recursive passing of the next elements of your of the functor algebra here, the F algebra. Whereas here the A is meant to be the current state and then the next state and then the current state and then the next state. The sequence of states being modified one after another. And but in here, this is still the class of all possible such step functions. Meaning, for instance, let's say if I have a vehicle, so the class of all possible vehicles, and when I pass it, when I tell it with this model, this is exactly what, this is the change fields function, and this is the increment UID function, then I'm saying this is the model of the car, and when you turn left, it's going to turn left like 5 degrees. Whereas with this other car that turns really well, it's going to turn 15 degrees or whatever, right? So instantiating the app interpreter is done here um, for our app model type, but it does two things at the same time. This, right? It instantiates it for the app model type, and it gives the specific interpreter. So the reason why I'm belaboring that point is because this is not written in a way that is thought to make interpreter to be switchable easily, whereas I see the ability to switch interpreters as one of the superpowers of this method, because you can then pretend that you have a component and mock stuff, and you can have an interpreter that logs or one that doesn't. You can have pure interpreters where you don't need it to do any side effects. So this equivalent of mocking, basically. For tests, so all of that is super useful. But here, this is not written in a style, I think, that makes this super evident. I think it's more written in a style that looks a lot like what other component framework, UI framework look like. So that's one thing to note. Maybe I will note it in our code, because that's probably where we'll end up spending some time today. So is this, no, it's not here. But here, do I even have an eval? Here, I think I didn't even start to do what I'm talking about. I think I just took the React Basic example and tried to move it to React Basic. Yeah, no, at this point, just the React Basic Classic example, and try to hook it into this other example. But I haven't even really started. So good. So we know that we'll have some eval from here. Might benefit from seeing more from oh boy. From making it easy to switch interpreters, test, and so on. Okay. Right, I think they were using this language of query. Ah, right. Query is the same as interpreter. I think query is what's it's called in Halogen. Like here is an interpreter. All right, that's where app query. Oh no, it's also called query here. I guess. Yeah, I think in Arthur Xavier's thesis, I think he talks about he defines some stuff that were not quite defined. I think in Phil's blog post at this point. It's a type query interface using a functor. So yeah, I like to see those better as actions, but yeah, because they can query something, they can be a command as well in a kind of CQRS style thinking. That's not the right thing to show. Yeah, if I go back to this example, that up. Here it just happens that indeed if you pass a string, then it's kind of like a query. No, it's not like it. This is more like an action, right? It's less like a query and more like a actually like here, have this string and do something with it. So it's more like a command. But if you had something like change field string to A, for instance, which is another very common pattern for free monads, then that would be a query. So it's in the secure, in kind of a CQRS language style. And sorry if I'm using so many acronyms, but CQRS would be command query segregation, command query responsibility segregation, which is an architecture, a software architecture pattern for not exactly distributed system, but large network systems. And I have some inspiration from that because this is sort of in a CQRS event sourcing sort of paradigm. Then this is potentially this is an event type right there. Except that in CQRS, yes, usually there's an effort to say that events are only things that change state. So here it could work because of the fact that this paired with an interpreter that changes state. But in reality, our interpreters can be effectful, and so in fact, that usually the CQRS folks don't want that. They would call something effectful a command, and they would use a different channel for sending the events, or even so therefore a different type. But I think that might not be necessary um, for us here. And maybe ever, but that's a big claim. So let's say just for us here. Okay, more complete example, blah. If I succeed in making a commodity component, the React basic hook component, that possibly can have components that are an actual J6 component with hooks, a Purescript React basic hook component with the hooks in Purescript, the UI in JSX. Yeah, that was another experiment that I was trying to decouple the Purescript React basic, basically trying to directly copy paste a component from a JavaScript code base and being able to hook into it with Purescript React basic hook. Yeah, right, or a completely Purescript components, but this is less of a focus for what I'm doing now. The main reason why this was interesting to me at the time was also because I was playing with React Native specifically. But anyway, this might be doable if I harmonize the interface such that there is a mapping between hooks and the coffee-free algebra. Right. So that's a bit more ambitious. And I think it's because also my head was quite a bit into the idea of, well, it connects us back to CRDTs, is this idea that we might have underneath events that are state change events that are um, sent and received through a kind of a distributed infrastructure, and that we use to kind of converge states. And so so that's what I see here in query streams. And but mapping hooks in the coffee-free algebra, I wonder, that might be about making hooks effectful, like how to deal with the effectful aspects. I do like the hook UX or DX, developer experience. I think it's quite nice to be able to separate effectful things from your pure rendering. It's kind of almost most minimalistic way to do that in a way that's still composable and prevents error by mixing and matching concerns inside the pure rendering side of a component. But as it is, it doesn't map necessarily too well with this interpreter. Although you could say that this is an effort at actually mapping it, at least because it looks quite a bit the same. Don't you see, like the pure rendering here with the component and then the effectful thing before? I suspect that this is what also Arthur Xavier had in his mind's eye. I do want to look at the fact that here we have another candidate for something that looks a bit like eval, but let's see, what does this do exactly? UI.effect, so I'm not sure what that is. Also, this is, yeah, what is this? A control component. Oh, right, that's commodic bind. Ooh, that's fancy. Okay, this is not easy to read because commodic code requires some thinking, or I mean, especially if you haven't seen it in a while. So this is the step function is defined here, and we unfold cofree on it. And so, right, we unfold cofree on it, but I think what we initialize it, I think, with task init, and then we compose this with then the thing that is we're going to really unfold with that step. And the step evals, right? So this whole thing is actually part of the evaluation loop, the step function. And then when we pass it is something where, oh no, I think this composition actually, is it just to persist? Huh. Yeah, the thing that I need to remember is that this component has a type, but then when it will be ran by something that's higher up in the code base, like a main or maybe UI, where it's going to be loaded, and in that case, I think it was going to be, what is it going to be? Cofree app, choose Cofree app, app component, right there. So it's going to be passed to the toReact thing with task Cofree, which is going to be whatever is persisted. So that's, I see this as the initial loading still, but I think the moment we do toReact, I think that's the moment where it actually then do the sort of the initial, what in the initial code for that Phil wrote is really the explore stuff. It's the stuff where the rendering occurs. So I think that if we look at the code for React, then I think toReact call that explore, which is the similar thinking of Phil's original Explore, which is really where that's the workhorse of Purescript React Explore. That's where the two pairs, that's where the comonad and the monad meet, and with this fancy bow tie thing, like the monad is paired with the comonad there, and we get such a pairing, and we get a initial space, I think, in this case, and then when we have that, then we know to react to any action, or right, what I suppose Arthur calls a query. So any such instance of which is something basically our monad, our navigation monad, like the one that's steering the wheel. We can react to any of these things by exploring the comonadic space that we're in, moving from one point or one part of the comonadic space to another part. And I think part of it is to do extract. Extract is what already? Extract is the comonadic extract, right? And that's it. Yeah, we get the state from. So that's a React. Oh no, this doesn't even use React. Oh no, it does. Yeah, it's a React DOM. It's a React DOMism, I think. This thing, like the React this stuff, and that's been removed, I think, mostly from all of the Purescript React Basic stuff. But I think the approach here is that you get current state from the component, and with this current state and a send function, which knows how to take a monadic action of units, which is the beauty. Like that's where like a lot of the unwrapping, like that makes me think of a regression scheme actually. Is that, or even that, we had this chained, um, like the total monadic value might be a long chain of navigation actions, right? But here we're able to focus on just the one, and based on that, just the one, we can also, um, through the pairing, because we have a comonad, we know what the state change that we need to do is. Plus, we're able, in this case, to also have some effects. If we no, actually, that's I'm not correct here. I think that okay, the effect that we have, and this is using the old school F monad from Purescript that's been deprecated a while back, which in fact you could say is deprecated in favor of something like Purescript run in terms of an extensible effect approach in the library rather than in the base. Transform state is basically effectful because it changes the state of the React component. But the pair const ID m duplicate with the m here, that is pure, and that is the state change. And so it could be that actually what Xavier did here is make this a little bit separate. Let's see. This also uses this sort of old. It's not old. It's the underlying implementation of the React, the Purescript React library, and the Purescript React Basic takes a different approach where there's no this. But yeah, so in this case, I think we see that explore algebra. Yeah, that's this here. I think the underlying assumption is that there's a pairing between the algebra F and comonad W, but here it seems like it's missing the fact or missing the opportunity to say, well, but this is co-free algebra. This is a co-algebra G, and they can pair together. But I think the the idea is the comonad W is the one that underlies the React components, and that one is not co-freed. It's not using this way to represent um, the the interpreter side of things. It needs to pair, but it's not as I mean, it needs to pair, and we see it pair in the example. In fact, right? Where did I? We see it pair in the example. App query and app interpreter pair, but I suppose that so we have app query and app interpreter, and then we make a app action from the query and an app space from the app interpreter, and that app space becomes the comonad, and app action becomes the monad. But then for some reason app action is called algebra F. I think it could be monad M. But this looks like something else happens here. Because the 4A FA2A is indeed that's I mean, I think I've seen this indeed being called algebra elsewhere, but I think it's really it's also an interpreter, isn't it? Something such that when you have and so for so that's for all A, but also for all F. Oh, is this using this thing that in fact you don't even require F to be a functor? So you can generalize things even more? It might be, but I think that it might, I mean, I guess in this style of functional programming, usually you chase like the most general formulation as possible. Here it feels like it's obfuscating something, but maybe there's something I'm not understanding exactly quite yet. In fact, algebra F, yeah, it's a value. That's one thing. There's no constraints on F here. And algebra F is a value. So when we pass to, when you use to react, we pass it for free app component task co-free. And when we pass it task co-free, that's the initial value, that's the task in it. And then we get back a React component app space app action. And so to React is a React component, takes that React component, but there's something missing. The component, well, okay, I'm not understanding something here. Is there a different to React? UI to React. Is this compile even? Sorry, don't mean to be dating things, but hold on. Co-free.app component. This is the type. Co-free.app component. Co-free. Where is this algebra? To React. I'm not in the same repo. I'm looking at the implementation for Purescript of common at RSS. So there's a different formulation here. There is. Oh my. Ugh. Okay, so for September 2018, and all right, so this one is an earlier attempt, and so it was past this algebra. Okay, now I'm curious though. Hold on. I want to see how it works then in Purescript Common at RSS. What's the main line here? To react takes force. Oh. Yeah, so wow. Laziness, huh? So it means that to react in this formulation builds up a lazy. Where else is lazy used in this library? Because it uses a formulation of co-free that uses lazy. Is that the case? How is that dealt with here? Also does. So where is force used somewhere here? Force is used, but only as part of a definition for co-resume. And so maybe it's better encapsulated. And then where is co-resume used? Well, first of all, is it used here? No. It's used in the pairing. Interesting. So that's definitely a little bit beyond my understanding. I think I need to drill down quite a bit to understand this. But this looks nice and symmetrical. That's quite nice. And yeah, that's the instance for free T, co-free T. That's what allows to say, given any free and co-free instance, I can deduce that they're paired as long as I can create an instance of this type, right? Like that. I can actually go directly inside this the functor and the comonadic co-free functor here. Yeah. Very cool. So it seems like that's definitely more nicer, and that this earlier formulation, it was yeah. You can see it's not as. Oh no, hold on. This is yeah. No, that's right. It's not as symmetric, and or yeah. I think it's and that surfacing this force concern right there, that also feels like something is not right. So I'm glad that this is cleaner. Excellent. Okay, so sorry about that. So am I ready to write a little bit of code there, or what? So here I actually didn't think I was trying to head for the store state. I think at this point I hadn't learned as much as I've learned since about free and co-free pairing. And the truth is we can actually just model something very similar as this. And we can say, we can definitely have a counter model, but our counter action and counter space will be, oh yeah, I really didn't understand. Or, yeah. I didn't know like the store comonad, did it get past the same state as the state comonad? I mean, I still couldn't answer that question just from the top of my head, but I know that I decided to go for another approach here. And so am I going to need to get the free and I think I'm going to need to get the free and co-free definition from from Arthur Xavier's module here, and just to benefit from his work on pairing, but it means that I need to not import anymore. I think I was importing, well, the regular free. Oh, I wasn't. Yeah, because at that point I was just, yeah, I wasn't yet crazy about Frico free. Okay, well, yeah, I think that makes sense to import this. So let's go get it. It's right here. Uh, well, data functor pairing we are going to need, even though, again, that exists elsewhere. But for now, we'll import it because there's a good chance that it's been tweaked to make it work well with this approach, like the laziness, for instance. So let's remove a potential source of confusion here. And oh wow, machine. Yeah, machines, of course, because of more machines. That's amazing. Okay, hold on. There's control command pairing as well. Okay. Why not? Control command. I wonder why. There must be some convenience thing. Ah, yeah, select and move. That's definitely. That sounds completely right. That inspires me. Those names, select and move there. They seem very right. And the fact that they apply to the pairing as well. It's like if you have a pairing and a comonad and you give me a monadic value, then I can tell you what the resulting state is going to be. And if I give you a state space, and some one move onto that state space, then I get a new state space. I'm somewhere different in that state space. Beautiful. I'm sure these exist elsewhere under maybe the same, but maybe also different names. So it's good that it's a co-free monad transformer. And I suppose then that it's using the free library, that's going to be good because I think, well, we can double check. Yeah, Purescript free and free that's really definitely what we need. So let's install them, free and free And yeah, you know what? I think we can try and build again. I mean, our main looks crazy, but at least we should have free and co-free in scope now. We can just import them. Can import kind of a lot of the things here. And I suppose we're going to have to also import. I think this, yeah, this is mostly going to be duplicated. And yeah, we're going to have to. Oh, UI, we have it. Okay, so let's go. And data functor pairing has been defined multiple times. So I did have it somewhere. It'd be nice if you told us where, but I suppose. So it's possible that it's in free or free T, but more likely comonad UI has it. So I might need to just remove comonad UI because I'm now sort of importing the whole thing. Except if I started to fork, which is very possible. that I started to import Command UI and started to modify it. Let's check it out. Nope. Well, yeah, what am I saying? If it was forked, then it wouldn't be in that list. So let's comment that out. Okay, you don't know how to comment out down. Oh, you do. Okay, good. And what? And then we need to remove it from Spider.down, I suppose. Command UI, yes. Kind of doing it without the parent library, which is that how it's done? Yeah, that's how it's done here. He's not using the parent library here. So maybe I was making an effort to try and plug them together, but I think maybe that shouldn't be done. And okay, we don't have a same error. That's good. To-do code free task was not found. Yeah, I think I imported way too many stuff. Like all of these to-do things. I mean, persistence. Nah, we don't need this now. Okay, let's try again. UI.react was not found. Yeah, because I called it UX basic. But you know what? Let's also, just so that we can migrate progressively to the new thing, let's just get the React one as well, so that we can check that things work properly. Okay, go for it. And what else? To-do's persistence. Okay, yeah, that sounds like indeed. To-do's persistence. I thought I removed that. Model UI was not found. Model UI was not found. And that's Model UI right at the root. Yeah, with way to do monolithic action. Yeah, that's all great. And UI, I think I'm going to need source new file UI in here. And I think that this needs to be actually in UI right there. Yeah, I'm not sure why I did a rendering. It's just not. And yeah, let's go back to main here. Do I have a rendering here? Yeah, I do, right here. But I think I could have kept that, in fact, but okay. And we rebuild. Whoopsie. Under module tasks. That's right. It's because we. Right. So we're doing this with the counter model. Oh, right. So what is our. So that's our space, in fact. So the counter model is our space, and the app query or a counter, counter action, or okay, right. So we want to call this thing the action. Huh. Right. No, this looks like there's something maybe I don't get there. This is coming from. Can close this and close this and close this and close this. Okay, went too far. Main. Nope. To-dos, go free, app. Right, and yeah, what's in task? Tasks here. Space is co-free interpreter and action is free query. Oh, they compose, of course. It's on top of each other. There's the top level one and the bottom level one. So I suppose, yeah, I suppose we could do fine with just one level for now, right? So let's call it counter interpreter. I'd like to not call it query, but action seemed a little bit taken. How about events? And we'll need to import free and co-free instead of free and free T. And that. Where is co-free coming from here? But that's in the free module, I think. Okay, let's buy here. Cannot import type free from control. Yeah. Here. Unknown type counter interpreter. Yeah, that's right. So counter interpreter will be something like this. So and app model will be something like so. And app action will be something like so. And app query is, I think we said counter event. And no multi-tasks, so we still have tasks somewhere. A task. Yeah. So right now we can just probably just remove this. And right, so I was trying to do the list thing, but we can simplify just a counter. This will be counter interpreter, and query is now counter events, and app interpreter will be counter interpreter. And right, make it like so. Could merge free T counter event with free. And yes, because of the lift free here. And so it looks like we have tab errors now. Maybe I should have done that. We might need that terminal. And then we're missing lift free. Where is this? Isn't this in the free package? Semirings, free T, lift free T. Huh. Right. Yes. How does this work? Here we're creating monadic values that lift from that free function. So how do we do this already? I think if I look at Purescript run, there'll be an example. That's the first thing that comes to my mind. Lift F. Ooh, I think this might compile actually. Terminal. Good, it's not dead. Play it again. Yeah. Oh. NPM start. Oh. Parcel is not recognized. Okay. Yeah, that takes a while to install. Oh, it's parcel bundler. Yeah. Oh, is it that parcel bundler needs to be installed globally, maybe? I suppose I could have done npx parcel there, maybe. No entries found. Index.js output test.main. Test.main. What do you mean no entries found? Main.main. Oh, right. Okay, well, you know what? Parcel test slash index.html. Okay. I see. 2, 3, 4. Okay, well, whatever we did, it's working with a counter. I don't think it's work. Yeah, no, it's not working with the pairing at all. It's actually using this counter. So now we need to Frankenstein things, but at least we have a code base that works. So next time we'll try and replace this React, what I think is a React Basic component, and see how we merge it with this free approach here. So it could be that actually what we'll do is um, well, yeah, I'm not sure what we'll do. Well, I suppose we'll follow the Purescript command. So let me write this down in the log for next time. So we've been diving into this, and I want to copy the relative path to these two logs because I want to take another look at them next time. Continue looking at those logs, and then right, we might want to continue importing the Purescript community QI to do example. Into, well, let's copy that path. Where maybe the full path. Sorry about that. That means specifically use the to React from well, actually we copied that code. And yeah, this to React here. And yeah, I mean, start from to React from blah and implement React Basic dot to React. So that will give us the Purescript React Explorer machinery, and then we can sort of evaluate different styles, hooks maybe, and then also array of children, which is I think what I was looking at with those early types there of before I deleted them, and which is a fairly common thing in it's the list it's the list example, and I think it should be even already somewhere like in probably no, not in UI. It's not in here, but I think it's yeah, it's fairly common. It must be somewhere close because all of this list thing and the way to compose components side by side or um, nest them, all of this is part of the commodity QI approach. Um, yeah, I'm not sure. I don't understand why I can't find it right now. Maybe it was in the RSS1 actually, because I was pretty sure I was parsing those earlier. Yeah, those. So these type of combinators, wherever that went, so I guess that means something like find out what happened to the combinators that are here. So that would give us a sense of how these things play out. And then I suppose what I'm interested in then is to see how we might do a version where we try to just hook the hyperswarm events to this approach, because that I think will give us a sense of how well this event-driven paradigm works within the Purescript React Explorer, and then see whether actually then Purescript run streaming comes into play then at this point. Okay, so that's the program for next Thursday, and on Saturday, I mean, we're going to be exploring Haskell with Junai and Ryan, and yeah, doing some fancy things with GStreamer, hopefully, or get ready to do so. And that's going to be it. So thank you so much for watching, and I will see you on Saturday. Bye bye.